Hello, and welcome to our discussion on long division. We're going to start this discussion by recalling some of the things that we did when we were introduced to long division back in elementary school, and we used it to divide whole numbers. So let's remember some of the terminology that we used because they apply to polynomial long division as well. All right, the dividend in a division problem is merely the value that's being divided. And you'll find that value underneath the division symbol. The divisor, on the other hand, is going to be the value doing the dividing. And you'll find the divisor on the outside of the division symbol or in the front of the division symbol. A quotient is the number of times that the divisor can go into the dividend. And last but not least, the remainder. The remainder is a little bit tricky. If you think about the number of times a divisor can go into a dividend evenly, whatever is left over from the dividend is considered the remainder or the leftover. All right, so let's take a moment and try this problem. This is a problem like you would have seen in 4th or 5th grade, and we're going to walk through it and make some observations that will carry over into polynomial long division. Okay, so if I'm thinking about dividing 12,967 by 241, the first thing we would want to know is what part of this number, 12,967, can 241 go into? So you're going to start by the first number because can 241 go into 1? Well, of course, the answer is no. Can it go into 12? Still no. How about 129? Well, still no. How about 1,296 or 1,296? And the answer there is yes. So now we're going to estimate how many times 241 can go into 1,296. And I'm going to guess maybe 5 times. Okay? And so I would put that 5 over the last possible digit there. And then I'm going to multiply the 5 times the 1 is going to give me 5. The 5 times the 4 is going to give me 20. So I'm going to have a 0, and then I'm going to carry the 2. And the 5 times the 2 will give me 10. Plus that 2 is going to give me 12. So it looks like I guessed pretty well. And then the next thing I would do, of course, would be to subtract this. I would take and subtract the 5 from the 6, and I'd have 1. Then I move over a column and do the same thing. 0 from 9 is 9. 2 from 2 is 0. And 1 from 1 is 0. But notice I subtract every piece. Okay. Now the next thing I'm going to do is bring down the next digit, the 7. And then I'm going to think about how many times does 241 go into this part, the 917. So I'm thinking to myself, probably 3 times. And I'll try multiplying that through. 3 times 1 is 3. 3 times 4 is 12. Carry that 1. 3 times 2 is 6. Plus 1 is 7. Let's subtract this and make sure it's a good number. 3 from 7 is 4. 2 from 11 is 9, and 7 from 8 is 1. And since that 194 is less than the 241, that means I have a good answer here. So I could express my answer in one of 2 ways. I could say my answer here is 53 remainder 194, because this is the amount that was left over after the total number of times the divisor went into the dividend, right? Or I can express this as 53 and a fraction. That remainder would be That remainder would be on the top, and the divisor would be on the bottom of this fraction. Okay, so a couple of things as we translate this process into long division of polynomials, we are going to remember a couple of things. One of the things that we need to remember is our polynomials need to be expressed in standard form, which means we're going to start with the largest degree, and we're going to put the degrees in order from largest to smallest. From left to right. Okay, the other thing that we're going to keep in mind here is that we want to use placeholders if we have missing terms. Okay, what does that mean? Well, that means if our largest power in our polynomial is a third degree power, I should have every power under that third degree. I should have a second degree, I should have a first degree, and I should have a 0 degree or constant. Okay, so anything that's missing, even if the constant's missing, we want to use placeholders. That's going to help us keep our work organized and easy to follow. All right, let's try one of these problems. Okay, our first example is a fairly easy example. We have 3x squared minus 2x plus 5 divided by x minus 3. So we're going to put the divisor out front, the dividend underneath the division symbol. When we're using this process, we are going to focus our attention on the first terms. So think about for a second 3x squared divided by x. What does that equal? And you should be able to tell me that that's 3x. So that's going to be the first part of our quotient. We're going to say 3x is the first piece. And notice I put it above the like term, the negative 2x. That helps keep our work organized. Now we're going to take this 3x and multiply it through to the terms in our divisor. So 3x times negative 3 is negative 9x. And 3x times x is going to be 3x squared. Now we're going to subtract this whole thing, okay? And you can think about this as subtracting something in parentheses. Okay, so I'm going to distribute that negative through. And so when I do that, this 3x squared will be negative 3x squared, right? And this negative 9x will end up being positive. So I'm going to take away the parentheses here. And then we're just going to add this straight down. I've got a 3x squared and a negative 3x squared. That becomes 0. And then I've got a negative 2x and a positive 9x. That's a 7x. I'm going to take this plus 5, and we're going to bring that down. And then I'm going to start this process again. 7x divided by x, starting with just the first terms, okay? And so now I'm going to add a plus 7 here. And now I'm going to multiply through this part of my quotient with my divisor. So 7 times negative 3 is negative 21. 7 times x is 7x, okay? And we are going to subtract this, and remember it's like subtracting in parentheses, so I need to distribute the negative through. So that's going to be negative 7x plus 21, right? Okay, and so I don't need those parentheses anymore. All right, and so what's left is I've got this 26, and so I can't take an x, I can't divide an x out of 26. And notice that I don't even, when I set it up this way, after I have a constant over a constant like that, I'm done. Okay, so this problem is finished, and we want to express our answer. We would express it with a quotient, 3x plus 7, and then we're going to add the part of the quotient that includes the remainder. So 26 over the divisor would give us our final answer. All right, this next problem is a little more complicated. Notice that the dividend is not in standard form and we've got some missing terms. Okay, so let's go ahead and put our divisor on the outside. Our dividend will end up being 4x to the fourth plus what? There's no x cubed term, so I'm going to use a placeholder 0x cubed. There is a x squared term, negative 4x squared, and a plus 6x. And I have 0 for my constant. All right, and so we are set up and ready to go. So when I focus on those first terms, I'm going to start with 4x to the fourth divided by x. And I would be able to tell you that that's 4x cubed. So I'm going to place that on top of my division symbol above the x cubed place. I'm going to multiply that through. So 4x cubed times negative 4 is going to be negative 16x cubed. And 4x cubed times x is going to be positive 4x to the fourth. I'm going to subtract this whole thing. And when I subtract the whole thing, remember I'm subtracting like there's parentheses. I'm just going to keep those there. And so that 4x to the fourth is negative. But when I take that negative and distribute it to the 16x to the third, it's going to be positive. I'm just going to circle that positive to remind myself that I've already changed the sign. Okay, so I've got 4x to the fourth minus 4x to the fourth, that's 0. But then I've got 0x cubed plus 16x cubed, and so that's going to be 16x cubed. And now I'm going to bring down the next term, which is negative 4x squared. I start that process again, 16x cubed divided by x, and that should give us 16x squared. I'm going to multiply that through. I've got 16x squared times negative 4 is going to give us negative 64x squared. And 16x squared times x is going to give us 16x cubed. I'm going to subtract the whole thing, distributing that negative. And so this will become positive. And the 16x cubes subtract away. I've got negative 4x squared and positive 64x squared, so that's going to be 60x squared plus the next term is 6x. Focusing on that first term, let's go ahead and divide it by the first term of our divisor, 60x squared divided by x. It's going to give us 60x. Going to multiply that by the negative 4, give us negative 240x. Multiply that by the x, I'm going to get 60x squared, and then I'm going to subtract the whole thing. All right, I'm going to remind myself that I've changed the sign right there. And so that 60x squared, negative 60x squared, subtract away, and I've got 246x. Bring down the last term, plus 0. And so our last term to be divided, that 246x, I'm going to divide that by x. That's going to give me 246. So when I multiply that through, 246 times negative 4, I think that's negative 984. And then the 246 x here, if I subtract the whole thing, remember that that changes the sign right here, and we end up with a positive 984 as our remainder. So our answer, 4x cubed plus 16x squared plus 60x plus 246 plus 984 divided by x minus 4. All right, in our last example, I noticed that my divisor has a 3x squared and a 1, but no x term. So I'm going to put an x term in there. I'm going to say my divisor is 3x squared plus 0x plus 1. My dividend has a 4th degree, a 3rd degree, a 2nd degree. So I'll put those in here. But there's no linear term or constant, so I'm going to add those in there. All right, and just like before, this one's a little bit of a shorter problem, but just like before, we are going to focus our attention on the first terms, divide them out. So I've got 18x to the 4th divided by 3x squared. That's going to give us 6x squared, which belongs above the x squared here. I'm going to multiply it through to all the terms. So 6x squared times 1 is 6x squared. 6x squared times 0x is 0x cubed. 6x squared times 3x squared is 18x to the 4th. And I'm going to subtract that whole thing. And just like before, we're thinking about that as subtracting the entire expression, which means I'm going to need to change some signs. Okay, so I'm going to change this to a negative and this to a negative. And I'm going to go ahead and combine those like terms. 18x to the 4th minus 18x to the 4th subtracts away. 9x cubed minus 0x cubed is just 9x cubed. And 3x squared minus 6x squared is going to be negative 3x squared. I'm going to go ahead and bring down the 0x. And I'm going to proceed to do this again. 9x cubed divided by 3x squared. It's going to give you a plus 3x. Okay, multiply that through. 3x times 1 is 3x. 3x times 0x is going to be 0x squared. And 3x times 3x squared is going to be 9x cubed. I'm going to subtract the whole thing, which means I'm going to need to change some signs. The negative stays in place and the 9x cubed, but this is going to become negative. This is going to become negative. And now when I subtract, I've got 9x cubed minus 9x cubed. Negative 3x squared minus 0x squared is negative 3x squared. And 0x minus 3x is negative 3x. Bring down our last term, a plus 0. And I'll go through this one last time. Negative 3x squared divided by positive 3x squared is going to give us a minus 1. So let's go ahead and multiply that through. 1 times negative 1 is negative 1. Negative 1 times 0x is negative 0x. And negative 1 times 3x squared is going to be negative 3x squared. When I subtract that whole thing, that means I'm going to change some signs, okay? So this is going to become positive, positive, and positive, right? All right, let's circle them to remind ourselves that we've changed those signs. This will divide out. And we're going to have negative 3x plus 0x is going to be negative 3x. And then a 0 plus 1 will be plus 1. Final answer here is going to be 6x squared plus 3x minus 1 plus a fraction with negative 3x plus 1 in the numerator and 3x squared plus 1 in the denominator. See you next time.